Okay, so let's do the first example here, which is, we've seen this example before. So this is the derivative function, and mapping from P2 to P2, and the two bases for the space we're going to use is B is this, and D is going to be this basis. And so this is the mapping that we're going to be using, okay, to illustrate what we're going to do. And so the first is going to be the top. And so what we're going to do, and this is going to be with respect to the starting basis, which is B. Okay, so what we're going to do is, this mapping here is going to take what? It's going to take x squared, maps it to 2x, takes x, maps it to 1, and then it takes 1 and maps it to 0. So this is all by d dx, d dx, right? Okay. So, what does that give us? Well, now we're going to write the representation with respect to the ending basis, which is also B. And so we're going to get this then. Okay, so we get, so we'll write this one. This is going to give us what? It's going to give us the representation with respect to B of x, 2x. And that's going to be what? Well, with respect to B basis is going to be, again, we're coming back here, so we're going to represent that mapping with respect to the B basis is going to be this one, which is going to be 0, and then 2, and then 0. Okay, so that'll be the first one. And then the second one, right, 1, now we're going to write this representation with respect to the basis B of 1, which is going to be what? Well, we want 1, so there's 1, so this is going to be 0, 0, 1. And then 0, which is not represented here, so the only representation for this one is going to be the 0 vector. Okay, so those are the representations for that. And so it gives us our map, right? So the representation of the map. So again, T is equal to the representation with respect to B and B of what? It's going to be of the function. So what's the function? d dx. And so now the representation, so this is our matrix, is going to be what? It's going to be the matrix 0, 2, 0, 0, 0, 1, 0, 0, 0. Okay, so next, computing the matrix for the right-hand side involves finding the effect of the identity map on the elements of the basis B. Now, of course, the identity map does not transform them at all. So to find the matrix, we represent the basis B's elements with respect to D. Okay, so now that we got this, let me erase this part so it will go on to the next one. Now we're going to represent everything with respect to D. Okay, so representation with respect to D of x squared, the representation with respect to D of x, and the representation with respect to D of 1. Okay, so what are those going to be? Well, this is going to be with respect to D. So what are we going to do here? Well, here we want x squared. So x squared here. So we want this, but we want to get rid of the 1. So we're going to have a minus 1 here and a positive 1 here. So that's going to give us minus 1, 0, 1. Okay, that'll get us x squared. Now what about x? Let's go on to the next one. Okay, so now we want x, which is here. So we can have a 1 here, and again, a minus 1 here to get rid of this 1, and we'll get our x. So it's going to be negative 1, 1, 0. Oh, why is this hold on a second. Oh, let me make sure I have this written down right. Do I have the basis right? Yes. That should be a plus. I had it as a multiplication. Okay, now what about the number 1? Well, there's a 1 there, so this will be easy. It'll be just 1, 0, 0. We just need this one. We don't want these two. So it'll just be 1, 0, 0. And now what happens? Now we're going to put these together, and this is going to be our P matrix. And so this is P, which is equal to the representation. And this is going to be with respect to B and D, B comma D, right? B comma D. And this is going to be the identity matrix. And this is going to be negative 1, 0, 1, negative 1, 1, 0, 1, 0, 0. Okay, so far so good. Now with that, we have two options to compute the matrix for going up on the left side. The direct computation represents the elements of D with respect to B. So let's do that. Oops. Okay, so what we're going to do, we're going to use the elements of D with respect to B. And so the elements of D are 1, 1 plus x, and 1 plus x squared. And so now what we're going to do is we're going to, with respect to these, so how do we get 1? This is, again, straightforward. It's just going to be 0, 0, 1, right? For this one. This one, what are we going to do here? Well, we want x plus 1, so we want these two. So this is going to be 0, 1, 1. And then for this one here, we want this one and this one. So that's going to be 1, 0, 1. And that's going to give us the following matrix. which is going to be 0, 0, 1, 0, 1, 1, 1, 0, 1. Okay? The other option is to compute the matrix for going up on the left side. Is going to take the inverse of the matrix P for going down on the right side. So we could take the inverse of P here. So let's do that. Now, if we, again, how are we going to set this up? This is, I'm just going to set this up for you, and then, again, you can verify it on your own. So we're going to take P, oops. Oops. Ah. Okay, so there's our augmented matrix. And so now all you have to do is using the elementary matrices is reduce this so that there's the identity matrix on this side and then the inverse is going to be on this side. So if we do that, we end up with this. And this isn't too hard to do. Okay, and so the inverse matrix is on the right. And so that leaves the bottom of the square. And there are two ways to compute the matrix T hat. One is to compute it directly by finding the effect of the transformation on elements of D. Well, we could do that too, right? So let's write those representations. Right? Oh, actually, I'm getting ahead of myself. Let's do the same thing we did before. Let's do the mapping first. So it'd be 1, oops, and then we have 1 plus x. And then we have 1 plus x squared. Okay, and so this is going to go to 0, this is going to go to 1, and this is going to go to 2x. Okay, and so now represent this with respect to D, right? We're going to, with respect to D, we get our T hat, and again, I'm not going to go through the whole thing because by this time you should know what to do. Because if we write this as representation with respect to D, right, and with respect to D, all three of these with respect to the D bases will end up constructing this matrix T hat, which is going to be this. Now the other way to compute t hat, and this is the way we will usually do it, is to follow the diagram up, over, and then down. So we'll go up, over, and then down. Okay? And that's where the inverse, so that's where that representation comes in that we were talking about before, which I'll rewrite here. And so we'll get the representation with respect to d and d of the function d dx, which will then be the representation with respect to b and d of the identity times the representation with respect to b and b of d dx times the representation of d and b of the identity. And so this here is t hat. That is t. And the matrices then, if I put in the matrices, then we end up with this setup. See if you can see the bottom there. Okay, so there's our, now if you multiply that out, you'll get t hat, which is also on the board there. So I would recommend doing that just for practice and to prove it to yourself that it does work. And that's it.